So the next example would be one of those complex polynomials. We actually found the derivative of this in the earlier notes. If you go back and look at some earlier notes where we were doing derivatives, we actually found the derivative of this function in one of the earlier either notes or on a extra practice. So I've got my original function, which is the first one listed there, the x plus 1 squared, the 2x minus 3 cubed. Then I gave you the derivative simplified. So again, you would have to use the product rule, the quotient rule, and then factor it to simplify it. And this is the expression you get. And then define, so we're focused again on finding the critical values. We've already practiced finding derivatives, and so you should be able to find that derivative, so see if you can on your own. The critical value is when the derivative is either 0 or does not exist. Now this is a polynomial, so it exists everywhere. There's no problem in it. And so it's just the 0 case. So set the derivative equal to 0, and again, make sure you show that that's a key step. So I've got my derivative, which is 10x, x plus 1 times 2x minus 3 squared. And the reason why we have to solve it with that's why we practiced factoring earlier, is because this is where it's important. You get zeros from each factor. That's the zero factor property, or the zero product property. So 10x will give me a 0, x plus 1 will give me a 0. I happen to have two 2x minus 3's, right? That's the square means, but only one of them I need to find my 0, because they both give me the same 0. So solve each one of those, so I get x equals 0 as a critical value, x equals negative 1 as a critical value, and so I get x equals 3/2 or 1.5 if you prefer the decimal, are all my critical. So there's my critical values. Again, I'm not going to graph this. You can graph it on your own. But they're my critical values. So now my critical points, remember, are the y value comes from the original function. The original function was x plus 1 squared times 2x minus 3 cubed. So that's the original. To find my critical points, I take my critical values, plug them back into the original. So when I plug 0 back into the original, I get 27. So there's a critical point. Negative 1 back into the original. When I plug negative 1 in, well, it comes out 0, right? Because that gives me out a 0. And then 3/2, or it actually might be easier to plug it into the calculator as 1.5. Either is fine. You can either do 1.5 or 3.5. So 1.5, when I plug it into the calculator, gives me a really big number, 1,350. So I would assume this is probably a maximum, a local maximum, a relative maximum. And there's my critical points. All right, so that's sort of the last example I'm going to go through algebraically with you. The next two examples, I'm going to show you a graphical method. All right, so that's my next two examples. So I'm going to stop there, pick that up in the next video.